So, welcome back, attendees. It's time now for our second session. I hope everyone is very keen to enter the second session with me. So, let's begin the second and last session of the event with a panel discussion on cutting edge system modeling and simulation solution to optimize cost, range, and performance. And in this panel, we'll be having with us Mr. Rahul Mahajan, the Deputy Director and the HOD, Engineering Design Simulation Center, the ARI, Mr. Abhijit Londe, Senior Principal Engineer, Mahindra and Mahindra, Mr. Huzefa Asi, Co-Domain Head, Electrification System Engineering, Switch Mobility, Mr. Kumar Prasad Tilipalli, Co-Founder and CTO of Meta Motors and Energy, Mr. Bineet Bansal, Sales Head Automotive Comsol, and the discussion will be led by Mr. Yogesh Umbrakar, Vice President, Eatron Technology. Welcome all panelists on the screen, and I am handing over the session to Yogesh sir. But before that, I just like to have one request to all of our audience to put up their questions in the Q&A box, and our panelist will be happy to address at the end of the session. Yogesh sir, please take the charge.
Thank you very much, Pallab. Good afternoon, everyone, and greetings from the UK. From this side, and welcome to all the esteemed panel members as well as the participants. First of all, thank you, Pallab and eMobility Plus, for giving me this opportunity to really have a great interactions and connect with the panel as well as participants. I think, as Pallab said, the cutting edge technology solutions on the simulation front. This is really one of the most exciting topic and most needed or critical topic in the transitioning from the world to the EV world. We've been seeing the unprecedented kind of attraction in the EV cells over the couple of months, given the push from both the central government, state government, the kind of a policies getting framed up by the government in terms of the PLI schemes. The EV companies or the conventional companies are ensuring now there is a independent, specifically investment is coming into the engineering side as well to ensure the EV platforms are getting setting up. And also there are investments or investors are looking at EV sector in a totally different lens. We have seen the example of Tata Motors having the almost more than 1 billion investment, and it was really one of the key indicator that a lot of things happening in the world of the EV. Obviously, with this, the bigger transition and the potential there, I think the OEMs are really facing a lot of challenges also, especially on the design and engineering teams, the R&D teams, where they have been saying that they need to develop the product or launch the product within a shorter time, unlike the earlier times where they had a 3 to 5 years time frame for the overall powertrain development and the further design development or testing phase. But now those timelines are really crunching from the management side. A lot of pressures are coming. At the same time, the customers are expecting that the product need to ensure the range side, the overall cost aspects need to be reduced so that you can make EV as a really viable product in principle. So in these all such a challenges on the R&D front, design and development, we will try to understand what are these challenges really which OEMs are going through and how simulations are really trying to help them in principle overall. So we have a really good mix of the panel. So Kumar coming from the both the tier one supplier like battery, or they have a two-wheeler platform as a OEM. Abhijit coming from the Mahindra. We have seen the new Mahindra electric born vehicle. The I think the teaser was really great. I think there is a lot of hope with XUV 700. I think Mahindra is reshaping a superb way now. Overall, we have a Josefa who with the Switch Mobility getting a really great momentum, not just in India, but I've been hearing a good amount of things here in the UK as well now. So that is on the bus segment. And obviously we have a testing and the certification partners like ARAI, and the simulation solution provider like Vineet from ComSol overall. So maybe to start with, I would like to go ahead with a very generic question to the specific to the OEM, our panelist, in terms of what are the key challenges they are facing when they are trying to build on the EV side, and then how simulation is helping them. And maybe the second question I would probably like them to continue on was is like how much is really the impact of simulation is making them in terms of the particular design time saving or cost saving. If they can highlight certain numbers in terms of percentage, that would really help us assess the impact of simulations are making. So maybe I'll start with Kumar. Can you help us understand? Obviously, you've been a startup, you've been with the established companies, Eaton, Mahindra leading them, but now with the startup, how you have been able to build up your R&D base from scratch, and how the simulations or what are the challenges you're facing in that kind of a transition phase, and also how the simulation tools are helping you and how you are leveraging them. So yeah, Kumar.
Yeah, thanks for pulling me in on this, Yogesh. So I think the for any business entity for that matter, the triple constraints of time, cost, and quality are the boundaries of any execution plan when you look at, and naturally, be it at an established organization or at a startup, it's about how quickly are you able to get to an understanding of the customer problem that you're able to solve, and what's the architecture which is giving is trying to get you to that solution. I think these are two essential baits that any industry, for example, would look at, and e-mobility is no different in that fashion. I think the only element is here the kind of expectation right now in the market, having been the perennial 10-year away story. Right now everyone is looking at and staring at e-mobility in front of us. So I think that's a good a market situation, I would say. But the at the same point of time, it brings in a lot of expectations to the tier ones, to the OEMs, and also to the partner ecosystem, that you're coming together in really delivering a solution which matters, right? I mean, that's something which we all have to take cognizance to, right? Now, I think having said that, when you look at all the triple constraints, the objective would be what are the accelerations that you can do, how quickly are you able to identify the key challenges, and then essentially focus on critical to quality parameters, CTQs, if you look at in terms of product architecture or even business solutions when you look at. So I think there is it's a no-brainer that you can't continue to cut metal until you have a MVP which is proving you right? I mean, and that MVP has to be in a digital form in current age and form. And I think it starts with systems modeling approach, where you do, let's say, leverage 1D modeling to make sure that your system architecture is right. Your basically your focus is essentially to get an architecture level view, right? And then you get into a very detailed design phase where you're doing actual hardware related schematics, mechanical interactions, and then software architecture related decisions, where you're essentially looking at the controllers of your choice and everything else. And all of this is driven by data again. What, for example, things which are physical, where people are aware of, is powertrain sizing, vehicle packaging, and others. But there are very crucial decisions that you make on the controllers too, right? Which controller is going to help you out? What's the kind of memory that you're looking at? Is this, where does it fall in terms of the vehicle architecture? Does it need a security module? Is it a Evita high or Evita mid platform in terms of cyber security? Functional safety wise, where does it fall in terms of architecture? So these are crucial elements that you need, decisions to be made, because these are not something that you can postpone to a evaluation when your vehicle is actually built and you're testing them. And all of this, I think, essentially comes down to having a robust, system modeling and design analysis plan, the way I segregate them. And I think, at least practically from my experience, both at Mahindra, Eaton, and even now at startups, we are progressively cutting down, from anywhere between 10 to 30%, depending on the complexity in terms of timelines, depending on whether your focus is on powertrain to actual vehicle, launch. So I think that's something which has been a very crucial element in terms of the progress that the industry has seen in EV. Now, having said that, I think the only one caution that I want to make again is there's no substitute to a very robust design validation plan. Analysis gets you to a certain level in terms of building confidence, but but your experimentation cannot be on the customer on everything, right? I mean, you have to obviously have a robust design validation where you're building confidence. And when you're saying 99% reliability, you have statistical confidence that you're hitting there. Okay, both from a business standpoint and also from a customer standpoint. So I think all this is for me logically coming together. Digital twins and the digital thread, and then the real world scenarios. How do you bring everything together is where it actually matters. And it doesn't matter whether it's a established industry or a startup. I literally say that there's no this is the way forward for the industry from my perspective. Maybe too aggressive in saying that, but my experience basically lands me there right now, Yogesh.
Yeah, that's great. I think you covered the whole landscape very well coming, and as you said, there's no other option, to be honest. Then so no matter let's say it's established or the startup, and I think the way you mentioned the progressively trying to cut down 10 to 30%, it's very significant for sure. So thanks for your insights, and then I like one of the fact that the simulations are not the 100% where you would try to rely that design validation verification on the real testing. It cannot be 100% replaced. It just you come to that point and reduce those efforts on the testing side. So great. No, thank you very much. I think similarly getting into the question and trying to understand from the Mahindra perspective or the SUV segment perspective particularly. So maybe Abhijit, would you like to share your insights on the key challenges, how you are managing it, and what are the key simulation benefits you are ripping off within the Mahindra, or particularly being MRV very famous on the Research Valley side?
Yeah, thanks, Yogesh, and thanks, Kumar. We've been colleagues earlier, so nice seeing you after a long time. But thanks for this opportunity. So let me tell this thing, like the three major things what we discuss. The time, cost, and quality. So I would say performance. Since we have to meet the performance, and especially as you also said in your introduction, that though we are talking about BEV, which is your battery electric vehicle, but for Mahindra it is born electric vision. So that's where we are looking at it, and the whole idea is to have a complete platform strategy, and have this platform deliver the performance and the get it out in the minimum possible time. And the only way to do it is through a process which is nothing but the virtual validation, and that is nothing but the front loading. And at Mahindra, we have defined these processes for our conventional vehicles, where we have well-defined DVPs. So when Prasad talked about DVPs, I would like to clarify that these DVPs are not only physical DVPs, but what we have done is we have mapped the physical test to a virtual environment. So in essence, whatever you're trying to do physically has to be simulated, because that is what we are trying to do. That's what we are trying to reduce time by giving confidence upfront confidence before you actually get into the hardware. So that is what we are looking at. Now, from an OEM perspective, if you ask me, there are two things involved here, especially from a simulation perspective. First thing is the architecture. Traditionally we've been building the vehicle structures, we're building the IC engines, the transmission, and now you are with a challenge, where you have to put in a new battery, electric drive. So these challenges are, pretty new for us, and the key enablers for this would be, I would say, is to have the right kind of suppliers involved very quickly. The right suppliers, I would say, the right kind of simulation tools, because we've been using some simulation tools for certain kind of requirements over time, but now you got the battery, you got the e-drive, you got the controllers, so that is one thing, and especially the new tools, so, and the kind of expertise that you need to build. So I'm also facing challenges where we have to get the right kind of people to this kind of work rather than the conventional kind of simulations we were doing. So the simulations I would put in two buckets. The conventional simulation, mainly when you talk about conventional simulation, yes, you will talk about structural durability, you will talk about ride handling, you will talk about NVH and crash. And then there are these new simulations where you have to, do a duty cycle for the battery and for the motor to get the range. And the starting point is obviously the math models. That's what we are also banking on, getting the maths model correctly. And for this, as I mentioned, getting the supplier involvement early on is very important, because you need to plug in these modules into your vehicle model and then drive the performance, then you drive the architecture. So this is one set or one gamut of simulations, I would call it, the model based. You can use any tool here. We have colleagues from COMSOL, we have, MATLAB. So this is one set. Now, when you come to the other traditional simulations, you'll ask what is different in that. Well, I would say the simulations remain the same, but the challenges, they change. Let me give an example. Let's say if you're looking at NVH, perhaps in this case, now the engine masking is gone. You have no noise from the engine. So you're left with new challenges. You're left with challenges of road noise. You're left with challenges of noise from the HVAC system. And then perhaps you'll have higher targets. So the starting point for an OEM from us, for like us, is to actually have the right benchmark and even perhaps revise our targets, because the earlier targets are no longer valid. Just as I gave an example of the NVH as one of the cases. So I would say what we are doing from an OEM perspective is, first thing is to get the architecture correct. The first enabler I would say is getting the 1D models in place, getting the right kind of suppliers on board as quickly as possible, getting the right tools and the right people, and then we deliver on this. So one thing, as you're saying, Yogesh, as the time is running out, I just want to tell you that, in fact, earlier for our conventional vehicles, we used to do 3 loops of simulations. Maybe you have a loop 1, loop 2, loop 3. You won't believe, now we have cut down on completely 1 loop. That's how quickly we want to get to EV right now. We are starting with a concept and then directly get into a detailed loop, and that's it. So obviously it is a big challenge. It's a challenge because, to be honest, as an Indian OEM, for all of the Indian OEMs, it's a new thing for us, and definitely we will leverage expertise around the world to do this. So I think in brief, that's what I would like to share with you, what we are doing and what challenges we perceive, but we can discuss as we go along.
Sure. No, I think Abhijit, thanks for really putting the internal perspectives on how you're transitioning as you from IC engine world to the EV, and how you're, even the example which you gave from 3 loops to the 2 loops. Obviously, the confidence would get need to be increased when you are going for that 2 loops, because cutting down 1 loop, need to ensure that at the end of the day, as Prasad said, you don't want to do that experiment 1 loop at the customer end.
Correct.
It will be very expensive in all the way overall, going back. And then obviously one of the important point which I also liked very much is taking your partners on board, particularly as you said, on the 1D system level, unless you have that battery data or motor data available from your tier one suppliers, you won't be able to really uh, take a
Exactly.
optimization route in sync with their products for your vehicle system. Or unless you do that system, subsystem, and component together, then only you can achieve the optimization levels. Otherwise, it's very difficult to just assume something and then getting on, and then towards the end, finding issues with the no optimized solution in principle. So yeah, I think one of the point before coming to the Vineet, in fact, I would like to go back to the Prasad in that conversation where how, let's say, Prasad, you change the mode now and become a battery supplier or tier one supplier now. And as a tier one supplier, then how you think that you have been able to help OEMs now, for example, or how you think you could help OEM the way Abhijit said that they would like and they need to ensure that these tier one partners are with them, not just from the testing and supply perspective of the product, but also ensuring they become a design partner rather than build to print partner overall.
So I think this is definitely a very important thing, uh, both for the tier one and the OEM. Because I have stayed in both the shoes. I can understand how things would work. In terms of handshake. It starts with even the, I mean, any powertrain components. Not just the battery, but for you to understand the application use case, right? You can't just go in and talk about a solution which is going to work for them unless you've really looked at their application, any application use case too. I think that's where the whole thing starts, and it gets back to the conversation that I had earlier, right? There's no substitute to the start of activity at a 1D model, and then how does the overall discussion connect back through 1D to design tool to 3D and back in the loop. So I think as long as the approach has a clear handshake, I can clearly see that the industry is much more, I would say, open-minded right now. Thanks to how e-mobility is looking at things, where obviously there are constraints with respect to intellectual property and others, but beyond that, I think at a level where the data handshake has to happen, I think it is happening at both ends. And I've seen this, both in my times at Mahindra, then at Eaton, and now here at Matter too, for that matter. So I think that's where I would say this is actually progressing in a quite progressive way, where the conversation is about partners and not supplier OEM, kind of a conversation. I think that's something which is very important to know. Now, beyond this, I think it's also about how do you create libraries, right? I mean, it's very important, and I think Vinith is here. I'm sure he's going to touch upon this when he speaks about it. In terms of there's a bunch. I mean, there's a lot of heuristics that the industry is setting on. Though people talk about powertrain as a new concept, but essentially, uh, you know, it's just that the inflection point has reached in the industry, and there's a lot more reach. But lithium packs have been on testing for quite some time right now, and people. I mean, what I'm trying to say is about the people who are really doing products, not concepts. I mean, there's a big topic difference between anyone can make a concept, not everyone can make a product. I think that's the way we need to clearly identify. And especially when you look at products, there's a lot of information out there, and I think the opportunity is also to see how we are able to create these libraries, which is helping industry, both the tier one and the OEM ecosystem, to leverage them to be able to make their 20% calls which are making 80% impacts, right? I mean, that's very important. And it comes down to, let's say, topics like NVH that Abhijit mentioned, when it comes to conventional, let's say, IC engine based platforms, you are talking about noise essentially from combustion. You are talking noise about the entire BSR related topics coming from the vehicle. But here, the phenomena is also changing. You're talking about electromagnetic friction coming from electric, machines, the electromagnetics in terms of power electronics, and the same thing when you look at thermal scenarios on the battery pack. You are essentially talking about uh, how material science is attributing to better thermal propagation and thermal conduction and thermal propagation. These are it's a very fine line. One is actually helping you, the other one is actually helping you destroy, if there's a problem. So I think these are elements where it is very important to make sure that we leverage industry's heuristics to create these libraries which are available. And I think that's an effort where COMSOL, ANSYS, MATLAB, all of these guys play a big role, because they actually become a confluence where the industry, academia, tier one OEMs meet, the way I see it. And I think that's the way I look at it, in terms of enabling this whole process from an industry standpoint, and my view about this. And data sharing is far more easier right now because people understand that there's a systemic challenge. That's how I would want to conclude, Yogesh.
Thank you, Prasad. And I think you kind of added up one more really important point in terms of the library build up. Uh, and it's all again, as you say, also at the start in the previous response in terms of that ecosystem. So ultimately, now it is becoming a more of ecosystem game rather than just purely OEM and then supplier game or just third party scenarios. I think everyone need to collaborate more and kind of achieve the best for everyone in principle. No, thanks for sharing it, Prasad. It's really valuable insights. I would like to come to Vineet. Uh, I think you have heard a lot from uh, Prasad, Abhijit, in terms of what are the key challenges. Obviously, they have been leveraging a lot of simulations. Now, from a simulation tool provider or solution provider, how you see that? How what are the key challenges? Let's say first is what are the key challenges you see from your perspective where there are still constraint in leveraging the simulation by the Indian OEMs. That's one part. So what are the key challenges or limitations which are being still faced by OEMs in leveraging? Let's say they can give up maybe some Indian context because you've been heading it and you've been communicating or coordinating with a lot of OEMs in India. So maybe one is that aspect, and secondly, how then you are able to help them further to leverage those things. Maybe you can give some example. It will be great, but in principle, how you can help them and what are the bottlenecks which you see in where OEMs are still not able to leverage fully as you would expect in principle.
Yeah, thanks, Yogesh, for the question. And in terms of challenges, when it comes to EVs, it's mainly the battery and the motor where the simulation plays a vital role. And for both, coming to battery, the critical thing to model a battery is the data. So many OEMs, many startups, they start with some experimental data, some cycle life data, calendar life data. Uh, but the end result of the simulation depends heavily on the quality of the data. So data quality matters a lot for setting up 1D, 2D, 3D models, wherein the OEMs are looking to, or rather the companies are looking to, check the performance in terms of capacity fade, like how the battery is going to degrade over the number of cycles. And the second important factor that we see is the thermal management of the battery packs. So it entails basically, the thermal management mechanism. Will it be air cooled? Because in two-wheelers, not much room for liquid cool, or because the cost goes very high. So not very options for the two-wheeler companies to accommodate phase change materials, or rather more advanced sort of cooling mechanisms. But when it comes to four-wheelers, three-wheelers, the scenario changes very quickly for thermal management, and oftentimes the companies are struggling with the best thermal management mechanism, because it all depends on the cell performance. Like Prasad was mentioning, the electrochemistry of the cell decides the thermal behavior of the cell under various operating conditions. But getting to the electrochemical data is again a big task. Many companies are not able to do that, so that's a big challenge. Then they rely on mathematical data, which may or may not be sufficient. And when it goes to some advanced applications like thermal runaway, so the triggers to the thermal runaway, understanding how the thermal runaway may occur. For instance, it may occur from some mechanical loading in a situation of a crash, or it may occur internally due to electrical short circuiting. So understanding these scenarios, and then understanding the propagation of thermal runaway, and how it's going to impact the vehicle, how long it will take to reach a certain temperature. So to do all that, I mean, data is critical. Without data, these models cannot be built. But what we are doing is, we have some models, some very accurate models, wherein the data can be inserted. Either it is mechanical data or electrochemical data. It can be inserted, and then some basic understanding can be developed to begin with, and then those models are parameterized. So as the development goes on, then the model can also behave as per the development requirements, and can reach a different scale altogether. So coming to motors, again the challenge is what kind of motor should be fit in. Uh, there are number of motor variants available, and then another challenge of the motor is, one has to study the electromagnetic behavior. And the electromagnetic behavior, for instance, electric behavior can lead to heating, frictional heating. That is a coupled mechanism. Uh, becomes difficult to capture sometimes, and then the NVH performance of the motor has to be taken into account. That is critical for many applications across the two-wheeler, three-wheeler, four-wheeler, and then the heavy vehicles. Acoustics of the motor, because that's the major noise source. And then reaching on to more advanced applications, like how the motor cooling is going to impact the battery, because the motor is going to draw all the power for the cooling from the battery, and that will in turn impact the range. So for the climatic conditions of India, where the temperature could be 50 degrees Celsius, or could be around 0 degrees Celsius, that geography of India and these components being very temperature sensitive, so it's a big challenge for the companies to start with 1D, 2D, 3D simulations, to actually do it in a coupled manner, where thermal mechanisms, structural mechanisms, NVH, electromagnetics can be understood in a single platform. Otherwise, the sequential flow will take a lot of time, because if one has to do it in multiple platforms, it will take a lot of time, may consume cost as well, and still the teams and the companies may not reach the results that they are looking for. So these are the challenges. And COMSOL, what we are doing is we are democratizing simulations, basically, because COMSOL has been used for battery simulation in Europe, or motor simulation in Europe and US for almost 20 years now. We have some studies published by Fiat, which goes back to 2013. Toyota has used COMSOL. There are many other companies who are using. I cannot name them because they haven't published data out yet. But almost all the OEMs, major OEMs across the world, use COMSOL for battery and motor modeling. but they have the luxury of getting the data. But when it comes to the Indian scenario, data becomes very critical to set up these models and then make sure these models are performing well, giving them accurate results, and the design time is optimized. So we have some solutions wherein more or less this can be automated, and some hand holding can be provided by us, so that with available data people can reach some accurate results very early in the development cycle, and uh, be less prone to some design and simulation challenges which may uh, uh, which may impact their timelines and costing and product development cycles.
Sure. Thank you, Vineet. I think you covered up well in terms of what are the specific challenges associated with batteries, motor, both the technical and then the data related, and how you've been trying to leverage the certain data associated available with you and trying to at least get them started rather than having a bottleneck. Hey, I don't have a data, I cannot use a simulations scenario. So yeah, I think it's a good moment. I would somehow we have our other two panelists, Josefa and Rahul. I think they are facing some issues in joining. So maybe we will still continue with our existing panel, and then one of the important part which is appearing, and at least it is even to my mind to some extent. And maybe Abhijit, you would like to add up something on the SUV front, like obviously we've seen that two-wheeler, three-wheeler definitely making almost a big roadway on the EV side. Now Mahindra is foraying with Born EV, very big way as well. I see that now. But then on the SUV side, now what are the key challenges you see when, let's say, talk about SUV as a segment? Not necessarily it should be Mahindra. I can understand there could be a good in kind of a confidential things being it's not. But then as a generic, if you could give some uh, high level view in terms of SUV as an electric transition, what are the key challenges which you could foresee? Nothing probably is Mahindra as such, I can see, and I don't expect that you share the internal things, but technically you can probably project uh, those kind of challenges. And then what are the key benefits also if you see from the EV side on the SUV side, if there are?
Yeah. So I'll be more specific here, and perhaps I would like to get into some of the performance domains.
Yeah,
Uh,
sure.
so maybe I can just start with a perspective from an SUV architecture. So if you look at an SUV, you got a higher hood line, you got an IC engine sitting, and you got a prof shaft going to the back. So you got a tunnel, uh, and then overall you have a higher edge point. So the people are sitting much higher. So overall, if you see that, that's how the image of the SUV is, and that's what makes it the king of the road. But now, when you move from a conventional diesel or a gasoline kind of vehicle uh, into a EV based vehicle, the first thing that happens is the electric motor comes in and your engine goes out. So that gives an opportunity to bring down the hood to a lower level because it helps you to improve the aerodynamics. The second thing is now you can place the battery, under the floor, which enables you to bring down the edge point to a lower level. Obviously, to get a bigger range, you might increase the wheelbase, so it pushes the front wheel more front. So these are, I would say, mota the bigger impacts in terms of the architecture. Now, when you do this, the challenge, let's look at different areas to be more specific in that case. So let me start, let's say, from the battery. The moment you put in the battery and you remove the engine from the front, your weight distribution completely changes for the vehicle. And this has a major implication in terms of your ride and handling. traditionally what happens is you try to maintain a certain FAW, RAW ratios to get certain handling kind of characteristics. But the moment you reduce the load from the front axle, your vehicle starts becoming oversteer vehicle.
Yeah.
And this is one of the challenges that as an OEM, I think anybody will be facing, and there will be a lot of strategies into how to manage the vehicle dynamics, because the vehicle dynamics is going to be completely different from an electric SUV as compared to the conventional SUV, for one of the examples I would say.
Yeah.
The second area I again mentioned was, I'll come to that point again and be more specific about it, is the NVH. So as we said, your electric motor, I mean, your ICE goes away, and then your motor, which generates this electromagnetic forces, tries to generate sounds which are at very high frequencies. So you must have seen that the electric vehicles produce a very typical high frequency kind of sound. So managing these kind of frequencies is the second challenge, I would say. The strategies to do that, and that can be managed maybe at the source level, where we will work with our partners on doing that. And the second thing is obviously on the vehicle and the transfer path. The other challenge again on the NVH, as I said, the earlier maybe you might have some target for the road noise, maybe some target for the HVAC noise, but those targets will no longer hold now, because those noises will become much more prominent in the absence of the ICE, and obviously your wind noise will come into picture. So these are some of the major challenges I'm seeing on the NVH side at this point of time. The road noise, the tire noise, pretty annoying noises. You'll hear the small squeaks, rattles, etc. Now coming to the other area, and you know that Mahindra, we are always looking after the safety of the customer, and our vehicles are now 5-star vehicles in the GNCAP ratings, and this is the legacy and the commitment to our customers, and it will be no less in our electric vehicles as well. Now the challenge here is, you've got a battery which is an electric device which is highly flammable. So how do you look at safety in this kind of scenario? Because you might do a frontal impact or you might do a rear impact, but here you have to ensure that no matter from where the impact happens, you have a vehicle structure or a cage which is going to protect the battery. So I think that is one of the bigger strategy in terms of the safety kind of strategy that we will do on the vehicle architecture to protect the battery in terms of any crash event, from an oblique crash or whatever. And as Vinit was mentioning, obviously the challenge is modeling of the battery, modeling of the material specifically, getting the material kind of data. As you know that now in electric vehicle, a lot of lightweighting is there, so the conventional material also goes for a change. Instead of regular sill members, you have aluminum extrusions, which are connected maybe with special adhesives to the vehicle, So having the material properties, modeling of these kind of special materials is a challenge from a simulation perspective, and definitely the crash structure from an OEM perspective, which needs to be relooked in this scenario, is another challenge, I would say. So that's from the crash perspective at this point of time. The bigger challenge, which Vinit also touched and will be a bigger thing for us, is the energy management, the thermal management. And basically he talked about a lot of things like, the thermal runaway, which is a worst case scenario, and which can definitely lead to, degradation over time and quick melting of some of the components. So again, here the thermal properties and the prediction of the battery, the heat generation through a 1D simulation, and how do you pass it on at a higher fidelity models.
Yeah.
So one of the challenge perhaps with which Vinit can also look into, and what we as OEM faces, is that you have a lot of tools, you have different tools to maybe do CFD, you might have something to do NVH. But finally, we need an especially from an EV perspective, you need an integration platform which can bring all this performance on one scale, and you can talk to each other. So I think that is one of the challenges for us. Having this kind of platform where we can leverage the different tools to get these kind of simulations. We can have co-simulations or talking to each other. That is one thing I would say. Other thing, like what we are also seeing, especially from a thermals perspective, perhaps would be hybrid models. So somewhere, you don't have the sources. You may not have a source of heat because you're not able to model that. You may not have a source of noise because maybe in the initial phase you're not able to have more details on the electric motor. So how do you get these sources? So one thing is, through a benchmark test, and that is where you use hybrid models. So you can plug in the physical data into your simulation model and derive further performances. So that is one of the challenges that we are also looking at, as to how to plug in and have such kind of hybrid models where you have physical data as well as the test data. So I think thermal management was one of the areas I said. The cell package design, obviously some OEMs would like to do this in-house, and that's another expertise that we are looking at, that perhaps how do we do the entire cell package 3D designing? How do we do the cooling circuits around it? Those are some of the simulations that we are trying to do through our CFD. And yeah, I think that those were the 4 or 5 major areas which I'm seeing right now, apart from the the battery simulations or perhaps the motor simulations, I would say. Coming to the transmission, yes, the transmission simulations is something which we have expertise in it. Only the drive becomes an electric, but in terms of the bearing designs or the shaft designs, the only challenge would be how to keep the transmission noise low. So that is one of the areas that we are looking at. And finally is one of the bigger challenges we are facing is that, because now the simulations are not only multi-physics, but they're also multi-domain. So you have durability, you have NVH crash. And that's where we are also focusing on what we call as the multidisciplinary optimization. So we have to optimize our vehicle structure considering all this performance, because traditionally, what will happen. For example, let's say you have a durability guy coming up and saying, he needs to remove some material from somewhere. Perhaps that is needed for the NVH guy, and maybe the crash guy might also want it, or the crash guy may not need some material. So one of the tools that we are working intensively is on the MDO tool, where we can take multiple disciplines and try to optimize the performance. So this is what we are also trying to bring into our EV space right now. So I would say, yeah, these were some of the major challenges, from a simulation perspective, and the performance that we are seeing because of the ICE converting into an EV. But if there are more specific questions, then I can still continue the discussions. So over to you, Yogesh.
Yeah, I think Abhijit, you really, I must appreciate the broader domain which you covered, right, starting from the ICE to SUV in terms of the battery layout, how it will pose and questions in terms of the ride handling, the weight distribution, and then the NVH aspect, and also then back to the thermal management, the battery motor sizing selection, the challenges associated. And I think the last point, which is more important as well, and I think a lot of simulation companies are trying to get into that, is the multidisciplinary approach. As you mentioned, it's not just from the one perspective, because any component you design, it has to meet all your durability, fatigue, NVH, your performance kind of a target overall. So you cannot just look at, I would like to optimize the design only for durability or only for, because there'll be conflicts there. And at the end of the day, you would like to ensure that all the teams come to a same conclusion and it becomes optimized or best trade-off from all the perspectives. So yeah, I think those tools are really coming up. The one other good part which I also see that simulation companies are getting into is that integration. So like, how do I take the same in 1D model and try to, as I go further on the V cycle, how I can use the same model and add more data and add further fidelity within that, and how I am able to integrate with other simulations like 1D, 3D, both, not just from performance perspective, but how I can do from the thermal management or take that data on the vehicle dynamics front as well in principle. So I think there are a lot of, at least from my previous world, we had seen those kind of a thing, and we were working on, and I'm sure the Comsol and other solution suppliers are looking into that. So I think thank you, Abhijit, for really giving that broader perspective. I just thought of summarizing it very well further. Um, Coming to the similar question, Prasad, let's talk about, maybe I'll focus on the two aspect because you're from the tier one and then the two-wheeler perspective. And let's start with the probably two-wheeler, because we talked a lot about the battery, the key challenges associated. But then as a two-wheeler OEM, are there any, obviously, Abhijit mentioned as a SUV, it's a kind of a complexity is probably higher. But again, two-wheeler, what is you see the complexity level seems to be something similar, or there are other challenges beyond what Abhijit mentioned?
So I think, first of all, uh, I really like the way Abhijit, stitched together the whole thing precisely, in
Yeah.
terms of the journey that it happens in SUV. And I think, anyone who is in the automotive industry understands, every application brings its fair share of challenges too. What might look simple in one could be very complex in other, right? I mean, so I think the bigger topic in two-wheeler is essentially you're dealing with a vehicle which is inherently unstable, right? I mean, you're not like on four legs
Yeah.
from a overall vehicle perspective. And
Yeah.
essentially the degree of freedoms are also from a packaging standpoint are extremely challenging in terms of what do you do with the space, right? I mean, and this is an order of safety for any vehicle, that you would like to achieve. But at the same point of time, everything would demand space. Okay, space claim. And you obviously it comes down to how are you really coming together, bringing this together as an architecture, right? So for two-wheeler, I really want to pick up because all the attributes starting from electromagnetic friction, which is basically what Abhijit called as NVH because of electric motors,
Yeah.
right? I mean, to topics related to thermal management, and there's also a lot to do with the structural part which we did not touch. But essentially, people are talking about. I mean, OEMs are already in a scenario where we talk about battery as a part of your vehicle structure rather than a component which is getting into the vehicle, right? So all of these things have a common thread, be it a four-wheeler or a two-wheeler, the way I see it. The challenges where it is extremely critical, and I just want to deviate a little bit from powertrain and I think the batteries where we have almost beaten them to death today. So we if you look at in two-wheeler industry, fortunately, the e-mobility ecosystem has bought in very nice infotainment systems, I would say. From a very conventional looking instrument cluster, which has been staying for ages, I think the disruption that's happening on the infotainment side is huge, right? I mean, when you look at it from the way the screens have emerged into the EV platforms, and maybe that's a cue of how things are being done differently in the industry too.
Yeah.
Now, I think we also need to be very clear that this is an engineering challenge, and you know, just imagine throwing your mobile phone on the dashboard of your vehicle and expecting it to work after 5 minutes of exposure of sunlight, right? I mean, and you are expecting this whole ecosystem, where the telematics infotainment gateway including the modem to function, as intended in a two-wheeler environment where maybe you are in the parking kind of scenarios that India has. Your vehicle is essentially cooking in sunlight, and I'm coming from Ahmedabad, so you can understand. I appreciate it a lot more. Coming from the temperatures that we see here. But more than temperature, it's also about sunlight. What many people do not understand, the conversation on heat ends with ambient and actual operational scenario that is happening with respect to either a powertrain or an ECU that is functional. But what many people do not understand is, especially when an infotainment system exposed to heat is actually having a 7-inch screen, which is being hit by a continuous sunlight of about 150 lux when you're talking about somewhere in Indian tropical environment. That's almost like a constant current source charging your battery without a charging limit. To equate it, that means there's no end to what level of temperature it can raise. So when ambient of 50 degrees centigrade, you are essentially talking about, the infotainment modules maybe cooking up to almost 70, 75 degrees centigrade. Okay. And even more, I mean, it's a continuous build-up scenario that you're talking about. And now, when you look at the solutions that people talk about, most of the modems right now are non-automotive grade. Okay. And then we talk about, what is happening with respect to infotainment system in terms of electronics reliability is basically pushing it to almost a corner, which no infotainment system has seen, either in construction equipment or four-wheeler or a commercial vehicle platform. This is a very unique challenge. But you have to understand that the consumer or the customer is demanding this. You're in a digital world. You're already exposed to this. So I think that is where the cross-functional element and how do you get to, simulations which are able to bring in even this luminous intensity as a source of thermal challenge. Yeah. Right? I mean, this is a complete different domain that we are talking about. Right? Yeah. I mean, in terms of what we look at. And it's not a rocket science. If you go to simulation models, they are available. It is just about having that detail. Okay, don't treat it as a cluster. When you do engineering, you are responsible for reliability, because essentially that's a component. Whether you like it or not, no one touches the motor every day. Infotainment unit is something that the customer is experiencing. Yeah. What it is giving you as a feedback. Right, that's the way he's communicating with the vehicle. That's the way he's communicating to the outside world through as a gateway. So, and I think the irritants there become quite more prominent in two-wheeler. That's a challenge that comes to us. One example. I can go on and on this same thread in multiple other things. But the other very critical element, we have touched a lot about mechanical noise and acoustics. The other aspect of it is essentially electromagnetic noise, the EMI/MC related aspect. It's a very complex system solution that you are looking at when you talk about EMI/MC, because component level, you will understand that everyone aces it. The moment you bring together, you're talking about maybe a 5 kilowatts to 10 kilowatts switching in an inverter to close to a megahertz switching on your DC-DC converter on board chargers, and then you are talking about antennas which are functioning in a gigahertz, and all of this essentially coming together in the same two-wheeler ecosystem too. What it does is it exposes yourself to address this physics-based, inefficiencies that we inherently introduce into the vehicle by putting in plug and play situations, which is like common mode filters, XY capacitors, which are essentially doing nothing in terms of traction, which is not doing anything in terms of taking the customer from point A to point B. So this is exactly the place where if you don't get it right, you'll end up building weight on components which are not actually delivering anything to you, or essentially carrying dead mass. I mean, people will hate in the magnetics industry to me saying this. But essentially, if you look at it, that's what is happening. So the challenge is coming down to, in the real estate, how do you manage this? And this becomes a bigger challenge in two-wheeler. Because if you look at traditionally the automotive industry, you essentially find out the EMI/MC problems, and I've contributed my fair share to these problems too. In my previous lives, where we have discovered this in very late stages, gate 2 and gate 3. Then you're essentially solving them by putting filters on the harness, expanding connector boxes, including ferrites in there, and actual whole program goes crazy. This is multiplied 2x when you come to two-wheeler. In the scenario, because you're exposed to two-wheeler ECU environment which you're talking about, so it needs a very different thinking when you're looking at it from a system architecture standpoint. So I think I would not, let's say, belittle any platform or application to what kind of rigor that is required. I mean, and I'll come back to what I mentioned at the start. Anyone can make a concept, not everyone can make a product. I think the journey for us is for people to realize that we are here, and this is what Matter does. We are here to develop unapologetic products where people take pride. In terms of using the solution, you don't want to be in a situation saying that I have an EV, sorry, I cannot do this. It should be other way around. I have an EV, I can also do this.
Do this.
We come back to that is the bottom line of what we need to get to. And I believe the complexity also presents opportunities to look at the solutions different way. And that's where we are actually burning our night and day oil, to make this happen at Matter. Also for you to be aware of, Yogesh.
Yeah, no, thank you, Prasad. I think you really brought a good concept in terms of, not a good concept, let's say the product now. I should not say concept, because I think one should not be just developing the concept, but it should develop the product, which can be kind of proven for the end customer point of view and work in the real world. As you say, you've given a good perspective on the other sides beyond the powertrain on the vehicle, and particularly I think the dashboards and the infotainment are really two-wheeler. It's kind of, and it's probably, I can see also is related that it's a new thing, right? I mean, something people are not expecting it in, and their expectation would be, oh, it should be as smooth as I see in my car overall, but it is subjected to a totally different environment, as you say, such a directly sunlight exposed dust environment, the shock, and so on, many things overall. So yeah, it's a good point which you brought it out. Thank you for that. And then one of the aspect maybe I would like to get touch upon, and it's been talked a lot in terms of the new AI and ML. So maybe Vineet, how you see that in the simulation world, the AI and machine learning, is it really getting leveraged now, or how you see that AI and ML can be leveraged uh, for the simulation purpose as well? Because ultimately you generate a lot of data through the 1D, 3D, and so on. So how AI and ML can be leveraged? Is there any particular thought you can give? And I would probably like to extend that even to Kumar later on. But yeah, maybe Vinit, you can try.
Yeah, sure, Yogesh. So, when we talk about the CAE industry, it is not dependent on. I mean, the backbone of the industry is not AI/ML. That's a new industry which is emerging. There are companies who are providing solutions which are written in certain languages, and algorithms are being built wherein ready-made available data can be used. For instance, the data can be extracted from the BMS, or the experimental data can be used. And I haven't seen much, but what I've seen is there are robust algorithms, programs being built which can provide clarity in terms of capacity fail on batteries. And
Okay.
then primarily on batteries, that is what I've seen. But like
Okay.
Prasad mentioned, the gamut of the CE is not limited to batteries and motors. I mean, as far as the industry goes, it can be on the design stage, like how to optimize the designs before they go into CAE testing, validation, prototyping, and then production, so that after 1 or 2 years, the team doesn't reach a conclusion that the design was invalid.
Okay.
And so, as far as AML goes, I mean, it is emerging, but I haven't seen much.
Okay.
But what I've seen is only on the
Right.
battery side. But if you look at the CAE perspective, it can also do EMI, EMC, wire harnessing, ADAS.
Yeah.
A lot of visibility aspect is coming into electric vehicles, wherein companies are talking about installing multiple cameras to increase
Yeah.
the visibility, and how a lot of electronics is being added to the system, and how that is going to behave, as Prasad was mentioning, antennas and gigahertz and all that. But I
Okay.
haven't seen much of that going into AI/ML. Maybe Prasad can comment on it. Yeah.
Yeah, sure. Maybe I think Prasad, that we have a short time. Maybe a
Yeah,
closing
I think
comment on that
I'll
topic.
just quickly, but you brought up a very broad topic at the end, but I'll try to see what I can do here. See, I think the most of the AI and ML pieces of what's happening is also not just on board of the vehicle. It's a lot more off board. Okay, it's basically what you are doing with respect to machine learning algorithms to build prognostic models, right? I mean, and this is not limited to anything just on the powertrain as such, but people like me or Abhijit, we don't care. It's the entire vehicle that we matters for us, right? It's essentially the bottom line is how are you able to use information, how are you able to identify patterns, how are you able to detect issues which are going to be causing customer distress and is going to add to your warranty scenarios, and how can you alter this. I think that's where the data part of it, connectivity part of it is helping us. I think that's where the maximum use cases are, in terms of how things are happening with respect to the connected ecosystem. Other side of it is obviously, when you talk about much more adaptive controls, right, where you're using the driver behavior to look at, how do you modulate your control strategies to see that, he's getting the experience that he needs. Earlier, we had a set pattern. What has been given to that vehicle is a character that is delivered. Now you have an opportunity, within the prelims. I'm not saying that, get into topics where your range changes completely and then you're actually fudging data to what was declared in ARI. But we are essentially talking about driving experience, right? When you deliver different modes, how do you make it more relatable, right? A two-wheeler, in a sports mode, if I want to do a wheelie, I know there's a different way I need to take care of the vehicle dynamics. There's a way we need to really look at it in terms of what does it mean for my structures. And these things, you end up doing a lot in terms of validation, but I always respect customer because he will find a way to fail you.
Yeah.
Okay, that's
Especially in
the
India.
bottom line I would say. So I think that's where AI/ML literally helps you to crunch the information, and is able to present scenarios in a much more concise way. Even there too, where you can focus on validation and design analysis plan, like Abhijit said, it's not a DVP but a DAP too, DAP and DVP linkage, where you are able to finally deliver a robust product. I think even there, a lot of machine learning and AI is having a potential to contribute.
Yeah.
And I mean, if it comes to COMSOL or any of these 3D simulation tools that we are talking about, I mean, if you are able to, they keep saying, right, simulation is garbage in, garbage out,
Yeah.
right? And this is a old norm. If you are having heuristics of 10 years of data, where you have experienced guys like let's say Abhijit, who have set the tone, and if you are able to learn these patterns and guide the, a guy who is coming fresh from an industry perspective too, to make sure that he's not really making creating challenges when he does the simulation, but create that interaction, right?
Yeah.
That is also another application where I see the AI and ML can actually help on the simulation front too. So I think, as I said, we can go on this in terms of opportunities,
Sure.
but I would say, we limit to this for now in the context of time.
No, so thank you, Prasad. I think you still summarize it well, giving a various aspects, and thank you everyone. So I think because of the time limit, I think we're slightly overstretched as well, but it was really insightful discussions we had right from the key challenges associated with the SUV, two-wheeler, how solution providers are helping, and I think Prasad really brought up good aspects in terms of not a concept, the products situation. Abhijit really dwell on the broader spectrum of the engineering, the challenges associated from the engineering side, covering up broader domain of NVH, ride handling, the layout, the battery thermal management performance aspect. So I think it was really very well insightful and informative and interesting session. So thank you everyone. Thank you eMobility Plus for giving all of us opportunity to share our thoughts. Over to you, Pallab.
Thank you very much, esteemed panelist. We are so sorry that two of our panel members could not join due to some reason. But we all glad to witness a wonderful session once again. Yogesh sir, just a note to thank you for your excellent job on moderating this panel. So, can we just let's have a round of applause for all our energetic panel from the audience? Great.
Thank you, Pallav, for pulling us together. Thank you.
Yeah,
Bye.
thanks, guys. Thanks.
Thank you,
It was a
everyone.
nice discussion.
Thank
Have
you
a
very
great
much once again,
day
all of
ahead.
you.
Thank you.
But hello, the show is not over yet. It's time to witness the most awaited EV Manufacturing Week Awards 2022. I will just request all of you to stay tuned. We will just come back in next 10 minutes. So till then, I'm just signing off, and let's celebrate the success in next 10 minutes.